Good day, everyone. Today I'm so excited to share to you the first lesson in your subject Basic Calculus. It's all about the limits of algebraic functions using tables and graphs. By the way, I'm your subject teacher, Sir Jenesis B. Sueka. The lesson objective, we are going to illustrate the limit of the function using table of values and graph of the function. Let's have this introduction. Everyone has their own limitation. Knowing your own limit helps you understand why some things are favorable to you and some are not. So in this branch of mathematics called calculus, limit is one of the important lessons that you need to understand because it plays a vital role in the application of differentiation towards functions. Especially nowadays, we are in time of pandemic. So limits are very important. Why? Because every actions we are doing now should have limits for us to keep safe always. Let's have these limits of algebraic functions using tables and graphs. The limit of the function f of x is the value it approaches as the value of x approaches a certain value. As x approaches c, so the limit of f of x approaches L. This is according to Mercado 2016. So this is written in symbols as follows. So this one. The limit of f of x as x approaches c is equal to L. Okay, so let's have this one-sided limit. Is the value in symbol L as the x value gets closer and closer to a certain value of c from one side only. So it's either from the left or from the right side. So in symbols, so from the left, so we have the limit of the function as x approaches c from the left is equal to L. And from the right, we have this symbol. The limit of the function as x approaches c from the right is equal to L. So please take note this formula, these symbols. Okay class, always remember that if the limit value from the left side is not equal to the limit value from the right, then the limit does not exist. Or in symbol, then A. So in symbols, if the limit of the function as x approaches c from the left is equal to L is not equal to the limit of the function as x approaches c from the right is equal to L, then the limit of the function as x approaches c does not exist. So if the limit from the left is not equal to the limit from the right, then the limit of the function as x approaches c does not exist. Okay, always remember this. And reminder class that in writing here, if the limit does not exist, do not put equal. Okay? Just write the limit of the function as x approaches c does not exist. Then A. Okay? The limit of the function as x approaches c is equal to L is not the same as evaluating a function f of c because they are different in terms of concept. So the limit of the function gets its value by providing inputs and approaches the particular number, while evaluating a function is more like direct substitution process. Okay, how to illustrate the limit of a function? So we have this example, expressed in mathematical symbol, limit of the function x plus 3 as x approaches 2 is equivalent to 5. So we have this solution. So write down your given f of x equivalent to x plus 3 and your c is equal to 2. and your limit here is 5. So then substitute into the limit expression the limit of the function as x approaches c is equal to L. Of course, the answer, we have this one. The limit of x plus 3 as x approaches 2 is equal to 5. Okay? Very easy. Okay, how to solve the limit of the function? So we have this example. Number 1, with a given function f of x is equal to x plus 3, solve for its limit when x approaches to 2 and graph the function. Okay, in symbol, we have the limit of x plus 3 as x approaches to 2. So what will be the limit? Okay, the solution, step 1, we are going to create two tables of value. One for the inputs that approaches 2 from the left, and the other is for the inputs that gets closer to 2 from the right side. Okay, so the first table here, so the first column, x is less than to 2. So this is for x approaches to 2 from the left. The second column here is for y. Then the second table, x is greater than 2 for the first column. This is for inputs as 2 approaches from the right. And the second column here is for the y values. Okay, step 2. Choose x values that approach 2 from the left side and also from the right side. Okay, remember class that we cannot choose 2 because we are dealing with limits. Okay, we have this illustration. As x values or inputs that approaches to 2 from the left side. So you can choose negative 5, negative 4, negative 3, negative 1, 0, 1, or you can choose 1.5, 1.9, 1.999, okay? But never choose 2. And x values or inputs that approach 2 from the right side, so you can choose 5, 4, 3, 2.5, 2.1, 2.001, okay? After choosing x values that approach 2 from the left and from the right side, evaluate each input to its corresponding function and solve for its corresponding output. So our given here, we have the limit of x plus 3 as x approaches to 2. So the inputs for the first table as x approaches to 2 from the left, so we have 0, 1, 1.5, 1.9, 1.999, and 1.1999. For the second table, our inputs as x approaches to 2 from the right, so we have 4, 3, 2.5, 2.1, going to 2.001. Okay, how to solve the values of y? Okay, so first table, our if x is 0, the value of y is 3. Okay, how to solve that one? So remember that our function is f of x is equal to x plus 3. So if x is 0, we have f of 0 is equal to, so the value of x is 0, so 0 plus 3 is equal to 3. Therefore here the value of y is 3. How about if x is 1? So 1. Okay, so 1 plus 3 is 4. About 1.5. So 1.5 plus 3 is equal to 4.5. For the second table, if x is 4, the value of y is 7. So same function, f of x is equal to x plus 3. So if x is 4, so 4 plus 3 is equal to 7. So if x is 3, the value of y is 6. Because 3 plus 3 is equal to 6. Okay? Okay, for step 3, now that the output values on both tables are solved, so notice that it approached 5 as the inputs gets closer and closer to 2. So we can illustrate both tables as one-sided limits from the left. So you have the limit of x plus 3 as x approaches to 2 from the left is equal to 5. And the limit of x plus 3 as x approaches to 2 from the right is equal to 5. Okay, so notice here in the table, as x approaches to 2 from the left, the value of y, it is approaches to 5. So here, approaches to 5. So if x is 1.999, so the value of y is 4.999. So that is approaching to 5. How about as x approaches to 2 from the right? This one approaches to 2 from the right. So the value of y approaches to 5 also. So as x is equal to 2.001, so the value of y is 5.001. It is nearly to 5. Therefore, the limit of the function as x approaches to 2 from the left is equal to 5. And the limit of x plus 3 as x approaches to 2 from the right is equal to 5 also. Okay, for the step 4, since both one-sided limits from the left and right side is equivalent to 5, therefore the limit of the function x plus 3 as gets closer and closer to 2 is 5. So in symbols, the limit of x plus 3 as x approaches to 2 is equal to 5. Okay, how to graph the limit of the function. So use the coordinates from the table of values and plot them into a Cartesian plane. So this one. We will plot this one into Cartesian plane. Okay, so this is now the graph of the function x plus 3. So you will notice that this is a linear function, therefore the graph is a straight line. Okay, so 0 and 3 is here, 1 and 4 here, 1.5 and 4.5 is here. So as x approaches to 2 from the left, the value of y, it is approaches to 5. Okay, for the second table, 4 and 7 is here, then 3 and 6 is here, 2.5 and 4.5, 2.5 and 5.5 is here. Okay, so as x approaches to 2 from the right, the value of y approaches also to 5 in y values. Okay, so in this area, this one, this big circle, it is evident that as the x values approach 2 from the left and from the right, the values approach 5 from the left and from the right as well. Let's have example number 2. Calculate the limit of x squared minus 1 over x minus 1 as x approaches to 1 and graph the function. On this particular given, evaluating a function, f of 1 is equal to 1 raised to 2 minus 1 over 1 minus 1 will result into 0 over 0. So the answer is indeterminate. So, but in the application of limits, there is a possibility that you'll get a defined value. For this reason, we can say that solving for the limit of the function is different from evaluating a function. Let's have now the solution. So we are going to create two tables. So the first table, the inputs here is 4 as x approaches to 1 from the left. And for the second table, the inputs here for as x approaches to 1 from the right. As x approaches to 1 from the left, so we choose 0.5, 0.9, 0.99, and 0.999. As x approaches to 1 from the right, for the inputs, we choose 1.5, 1.1, 1.01, and 1.0001. Okay, next we solve for y. Okay, so the given function here is x squared minus 1 over x minus 1. So if x is 0.5, this one, let's solve. So 0.5, substitute 0.5 to the variable x. So 0.5 raised to 2 minus 1 over 0.5 minus 1. So to solve, this is equal to 1.5. Therefore, the value of y here is 1.5. So with same procedure, let us solve 0.9. So if x is 0.9, the value of y is 1.9. If x is 0.99, the value of y is 1.99. If x is 0.999, the value of y is 1.999. Okay? How about if x is 1.5? So with the same procedure, we can get 2.5 for the value of y. If x is 1.1, the value of y is 2.1. If x is 1.01, the value of y is 2.001. If x is 1.0001, the value of y is 2.0001. Okay, so as x approaches to 1 from the left, this one, what will happen to the values of y? Okay, it is approaches to 2. So if x is 0.999, the value of y is 1.999. So this is nearly to 2. How about as x approaches to 1 from the right, this one, what will happen to the values of y? So approaches to 2 also. Okay, so therefore we can say that the limit of x squared minus 1 over x minus 1 as x approaches to 1 from the left is equal to 2. And the limit of x squared minus 1 over x minus 1 as x approaches to 1 from the right is equal to 2 also. So therefore, the limit of this function x squared minus 1 over x minus 1 as x approaches to 1 is equal to 2. Okay? Okay, let us graph now the function. So this is the graph of the function x squared minus 1 over x minus 1. So this is linear again. Okay, class, notice that a hole here, this one, the hole, is visible on the graph because of the 0 over 0 or indeterminate result when x is equal to 1. Nevertheless, the limit is obvious because it is evident here that as the x values approach 1 from the left and from the right, the y values approach 2 from the left and from the right as well. Okay, so in plotting of points, so just plot these points in the first table. So 0.5 and 1.5, 0.5 and 1 is here. Okay, then 0.9 and 1.9 is here. Okay, for the second table, 1.5, 1.5 and 2.5 is here, and 1.1 and 2.1 is here. Okay, okay class, so that's all about our topic for lesson 1. If you have questions, clarifications regarding our topic, so just comment here in this video. Thank you and God bless you.